Hey everyone, welcome back to the channel. This is Aman Yadav, and today we're diving into one of the most fascinating and powerful technologies shaping our digital world, blockchain. But instead of just talking about Bitcoin or crypto, we're going to zoom into the real hero that makes blockchain possible: blocks, the building units of digital trust. By the end of this video, you'll understand exactly how blocks, chains, and hashing work together to make blockchain unbreakable. So grab your headphones, let's get started. So, what exactly is a block? Think of a block as a digital container. It holds a bunch of verified transactions. Once a group of transactions is approved by the network, they're packed into this block, sealed, and added to the chain. But here's what's genius: every block connects to the one before it, forming a long chain of data that no one can alter. You can imagine it like pages in a diary. Once you write something and seal it, you can't go back and erase it. That's why we call blockchain an immutable ledger. Every page tells the story of the network exactly as it happened. Now you might be wondering, why go through all this trouble? Because blocks are what make blockchain secure, transparent, and trustworthy. They give us data integrity. Every block has a unique digital signature called a hash. They make the system immutable. Once added, you can't edit or delete a block. And most importantly, they build decentralized trust, meaning we don't need a bank or middleman to verify our transactions. Everything is verified by the network itself, and that's revolutionary. Each block has two main parts: the header, which stores important information like timestamp, difficulty, previous block hash, and the Merkle root, and the body, which holds the actual list of validated transactions. Think of it like a book. The header is the title page, giving you the summary, and the body is the detailed story of what happened inside that block. Let's break this down a little more. Previous block hash, it's like a handshake between this block and the one before it, keeping them connected. Merkle root, a single hash that represents all the transactions inside the block. It's like compressing a big file into one small fingerprint. Nonce. This is the special number miners use to solve the cryptographic puzzle. Timestamp records the exact moment the block was created. Together, these pieces make each block unique, traceable, and secure. There are three main types of blocks. 1. The Genesis block, the first ever block in any blockchain. 2. Regular blocks, all the ones that come after it. 3. Orphan blocks, valid blocks that didn't make it into the main chain due to network delays or temporary forks. They're like the deleted scenes of blockchain. They exist but don't make it into the final movie. Here's a simple analogy. Think of a city's land registry book. Each page records property transactions, and every page references the one before it. If someone tries to change one page, all the following pages become invalid. That's exactly how blockchain prevents tampering. Blocks are created through a process called mining. Miners collect unconfirmed transactions, bundle them into a block, and compete to solve a complex cryptographic puzzle. Whoever solves it first adds the new block to the chain and earns a cryptocurrency reward. This not only validates transactions but also keeps the network secure, like thousands of computers constantly guarding the same treasure chest. Blockchain isn't just about Bitcoin anymore. Blocks are now used in supply chains to track products from factory to store, in digital identity systems to store credentials securely, and in smart contracts to automate agreements without middlemen. It's a technology that's quietly powering the next generation of digital systems. Alright, so we know what blocks are, but what about the chain? The chain is what links all the blocks together, like the spine of a book that holds all the pages in order. Each block contains the hash of the previous one, which creates a perfect, unbreakable connection between them. Now imagine if someone tries to alter one block, even slightly. The hash changes, breaking the link with the next block, and that instantly alerts the entire network. That's why blockchain is tamper-proof. If you want to fake a transaction, you'd have to change every block on every computer in the world simultaneously. So the chain isn't just a connection, it's a timeline of truth. It records everything that's ever happened in the exact order it happened. In fact, Bitcoin's chain has over 800,000 blocks, all perfectly linked since 2009. That's digital history you can't erase. So remember, blocks are the body, hashing is the heartbeat, and the chain is the soul that holds it all together. Now let's talk about the secret ingredient that keeps all this working: hashing. A hash is like a digital fingerprint, a short, fixed-length code created from any data input. If you type hello, you'll get one hash. But change it to hello with a lowercase h and boom, you get a completely different hash. That's called the avalanche effect. Tiny input changes cause huge output differences. Hashing is one way. You can go from data to hash, but never back from hash to data. That's why it's perfect for security. Every block stores its own hash and the hash of the previous block. So if anyone tries to change even one bit of data, the hash breaks and the entire network knows something's wrong. This chaining of hashes makes blockchain immutable and self-verifying. No central authority needed, just math doing its job perfectly. To be useful, a hash function must have four key properties. 1. Deterministic, same input, same output. 2. Collision resistant, two different inputs can't give the same output. 3. Pre-image resistant, you can't reverse engineer the original data. 4. Avalanche effect, small input change warrant totally different hash. Different blockchains use different algorithms. Bitcoin uses SHA-256, Ethereum uses KCAC, and new systems are adopting Blake 3 for speed and quantum resistance. In short, hashing is the mathematical magic that makes trust possible. Hashing isn't just theory, it's transforming industries everywhere. In cryptocurrency, it verifies every transaction and protects billions of dollars daily. In healthcare, it secures patient records and prevents tampering. In supply chains, it tracks goods and ensures authenticity. In smart contracts, it guarantees agreements execute exactly as coded. But the future also brings challenges, like quantum computing. These new machines could someday break current hashing algorithms. That's why researchers are already developing quantum-resistant hashes like SHA-3 and Blake-3 to future-proof blockchain security. So, here's the big picture. Blocks are the foundation, where data lives. The chain is the connection, keeping everything honest. Hashing is the heartbeat, protecting data with math. Together, they form a system that's decentralized, transparent, and trustworthy. A digital world built not on promises, but on proof. If this video helped you finally get how blockchain really works, drop a like, share it with your friends, and hit that subscribe button for more fun and easy tech explainers. This is Aman Yadav, signing off. Stay curious, stay secure, and I'll see you in the next video. From JD College of Engineering and Management, Nagpur, thank you.